Okay, now a single negative ion has mass of 6.68 exponent negative 27 kilogram. The particle moves clockwise in a circular path of radius 3.25 cm with a speed of 1.5 exponent 4 meter per second. Okay, determine the direction and strength of magnetic field. Okay, so the question wants us to find the direction and strength of the magnetic field. So this is what we call the B. We want the magnetic field, the strength of it, that means the magnitude of the magnetic field strength, and also the direction. We need to give direction. Don't forget to give the direction. No direction, you lost marks. So what is this? We have, it tells us this is a single negative ion. So I already write here. It's like we don't know what kind of atom is this. So just put as X, and it is a single negative charge. Single negative charge means one negative. Single negative means one negative. So one negative means the charge is one electron. Charge is one electron, 1.6 exponent negative 19 coulomb. We already have the charge. Okay, this one. And then we have the mass also. Given us the mass here also. Okay, and it's a negative charge. Negative charge is given the mass also. And what else? He say move clockwise. Clockwise. That means you can imagine the particle move like this. Like here, clockwise. Clockwise. Follow the clock. In a circular path. Circular path of radius. Give us a radius here. So the radius of this circular path is 3.25. It change to meter. Change to meter. Exponent negative 2. And also give us a speed. This is the V. Speed of what? Speed of the charge. Speed of the negative ion. Speed of it is V. 1.5 exponent 4 meter per second. So I already have the speed. Find the direction of the magnetic field. Okay. So I'm pretty sure this charge experience a force. A force. That's why it moves in a circular motion, as though it experienced a centripetal force. So what do you think is the direction of the force first? Before we want to find the field, first we need to find the magnetic force. Okay. So I can imagine this particle move clockwise like this. Clockwise. So let's say the negative charge is at the top of the circle here. So if it is clockwise, means the negative charge at the top here is moving to the right. So I draw like that. Okay. So what do you think is the force? First of all, before we want to find magnetic field, find the force. So this negative charge, in order for it to turn clockwise, so we pretty sure the force is towards the center of the circle. This one. So this is the what kind of force become the centripetal force? It must be the magnetic force. Magnetic force become the centripetal force. This force is perpendicular to the velocity. Okay. It is towards the center of circle. Towards the center of circle. So what do you think is the field? What is the direction of the magnetic field that produce this force? Okay, so I have written down drawn here, as you can see. Let me show you. Okay, so I can see from here the magnetic force is towards the center of the circle. This is a center, center of circle. So magnetic force must be in this direction. This the centripetal force. Okay. So now let us determine. Okay. use your right hand rule. Yeah, use your right hand rule. So the velocity is the finger. Yeah, the forefinger is the velocity. Velocity, but your force is downward. Your force is downward. But this is a negative charge. This is a negative charge. Remember, for negative charge, the force is opposite the thumb. The force is opposite the thumb. So that means the force is downward. The force is downward. So the thumb should be upward. The thumb should be upward. Velocity is the finger. Yeah, velocity is the finger. So force downward means my thumb should be upward, because for negative charge, the thumb must be opposite the force. The thumb must be opposite the force. So velocity this way, my thumb is upward. My thumb should be upward. Understand? My thumb should be upward. My thumb should be upward because my the force is downward. The thumb should be opposite the force. Okay? Like this lah, like this. Understand? So, what do you think is the direction of the magnetic field? My magnetic field is my palm. Remember my palm? My palm? This palm? Yeah, this palm is the magnetic field. So again, yeah, let's look again. Velocity. My forefinger is the velocity. Velocity. My thumb opposite the force. My thumb opposite the force. My thumb actually represent the force, but because it's a negative charge, my thumb opposite the force. Force is downward, so my force is upward. Because the force is downward, so my thumb is upward. Okay. And my palm is facing into the page. You see that? My palm is facing into the page. Into the page. So what going into the page? My palm represent the magnetic field. My palm represent the magnetic field. So it's a magnetic field go into the page. Magnetic field go into the page. So that's it. We got the answer. My magnetic field is going into the page. Magnetic field is going into the page. Yeah. My magnetic field going into the page. So this is the magnetic field direction. Understand? That's the magnetic field direction. Okay. Let us write it down. Yeah. Let's write it down. So I already got the answer. Okay. Yeah. So my answer is my magnetic field is going into the page. Let me use the blue one. Yeah. Magnetic field go into the page. Magnetic field go into the page. Okay. So this is my magnetic field. Okay. That's my magnetic field. Go into the page. So now, that I got the direction already. So what's next? Find the magnitude. Yeah, let's find out the magnitude. So as we know that this is the magnetic force provides the centripetal force. So FB equal to FC. Okay, FB is the magnetic force for moving charge is BQV sine theta. BQV sine theta. And because we know that the velocity and magnetic field, they are perpendicular. You see, velocity to the right, magnetic field go into the page. So they are both perpendicular. Velocity perpendicular to the field. So the angle between velocity and magnetic field, the theta is 90 degree. So sine 90 equal to 1. Okay, sine 90 equal to 1. So disappear. So this one become 1. Yeah, this one become okay, this one become 1. So I left with B. I left with, oh, here also velocity and here also the velocity and the velocity here cut off. So I got BQ here, I got BQ here, and then I got MV over R here. What I need to find is the magnetic field. So magnetic field equal to MV over RQ, MV over RQ. So that's it. So just substitute all the values. So what's my mass? My mass is okay here, given the answer. So my mass is 6.68, negative 27, and my velocity is okay, 1.5, exponent 4 divided by, what's the radius? Radius is 3.25, exponent negative 2. Yeah, change to SI unit already. No longer cm. Now, how about my charge? This is a single negative charge. Single negative means one electron. 1.6 negative 19. 1.6 negative 19. Okay. So what's my magnetic field? Magnetic field, I got 0.0193 Tesla. That's the, or you can also write as a verbal per meter square. Yeah, it has two kind of unit. Normally we write Tesla. So what's the direction again? Just now I got the direction already. Direction of magnetic field is into the page. So you must write there. In direction is into the page or into the paper. That's the answer. Both magnitude and direction. Okay, is that correct? Yeah, 0.019 Tesla and into the page. Yeah, that's correct. Okay, that's it for this video. Thank you. See you again.